I'm 7 meters and 56 centimeters away from the basketball net, and after picking up the ball, I raise it to my head and push it towards the net, making it travel through the air while moving left to right at an angle. It then hits the backboard and rim, making a clanging sound before it goes through the hoop and falls to the ground. Three curriculum connections include the presence of projectile motion from the kinematics unit, as the ball goes through a parabolic motion upon its release and under the influence of gravity. As well as this, there is energy transformation, as energy transforms between gravitational potential energy and kinetic energy throughout the shot energy unit. Finally, there's sound waves created when the ball interacts with the backboard and rim, while it makes a clanging sound, waves unit. Projectile motion is a concept within physics that describes the motion of an object or projectile as it undergoes a two-dimensional curved trajectory while under the influence of gravity. In this case, a projectile is a basketball. The time of flight is the amount of time it is in the air, while the range refers to the horizontal distance traveled. The range in this case is 7.56 meters, while the time of flight is 1.17 seconds. Projectile motion calculations can still be applied to trajectories that begin or end at different heights, with the basketball starting its trajectory at the point of release and ending when it hits the backboard, as after that point is not only under the influence of gravity. Two-dimensional vectors are shown as basketball moves on the x and y-axis, with the resultant vector being the displacement. In projectile motion, the acceleration on the vertical plane is uniform at negative 9.81 meters per second squared, the force of gravity, while the velocity of the projectile on the horizontal is constant from its release. To calculate values such as the maximum height or the final velocity, launching a projectile at an angle to the horizontal must be considered. The kinematic equations are required. You must calculate values on both the horizontal and vertical planes for values such as final velocity. Given values include acceleration on the vertical and horizontal planes being negative 9.8 miles per second squared and 0 miles per second squared, respectively. Other applications of projectile motion in life include sports such as golf or football. In both of these applications, the parabolic trajectory of the ball continues until it hits the ground or is caught while under the influence of gravity through the entire trajectory. Other objects that are projected also is projectile motion, such as a water hose or a cannonball. The law of conservation of energy refers to how energy is neither created or destroyed. It is only transformed into a different type of energy without being lost. There are many different types of energy and conversions, including kinetic energy, gravitational potential energy, and sound energy. In the shot, all three are present. Kinetic energy refers to the energy possessed by moving objects, or the basketball. It can be found by multiplying mass by velocity squared and then dividing by 2. Gravitational potential energy refers to the energy an object possesses from its relation to the surface of Earth, the basketball's height. It can be calculated by multiplying mass by the force of gravity being 9.8 miles per second squared, and then multiplying it by the height. By weighing the ball and using the height of the ball at a certain point, it can be derived. There are many other minor forms of energy transformation, such as the thermal energy. However, sound energy transformation occurs when the ball hits the backboard as some of the kinetic and gravitational potential energy gets converted. Through the entire process, there is no loss of energy. It just gets converted from the initial kinetic and gravitational potential energy to increased gravitational potential energy and decreased kinetic energy as it reaches its apex. Then the reverse happens on its descent. Between the 2 points of the basketball's arc, various values can be calculated, such as the second or first velocity or the height between the 2 points, by understanding that as energy is conserved, the additive gravitational potential energy and kinetic energy will be equal for both points. By using the law of conservation between these two forms of energy by using the individual equations added together, you can solve for the values. Examples in real life can include light bulbs, as they convert electrical energy into light energy. It can also be seen from turbines that use falling rainwater to create electricity, as the gravitational potential energy of the raindrops are converted into kinetic energy as they fall, which is then converted to electric energy. Sound waves are created when an object's vibrations move through a medium before hitting something. There are three different types of sound waves, being audible sound waves, which are within the human's hearing of 20 Hz to 20 kHz, infrasonic waves, which are sound waves below 20 Hz, and ultrasonic waves, which are sound waves with frequencies above 20 kHz. In this case, the basketball hitting the backboard and rim to make clanging noises falls under audible sound waves, as we are able to hear it, with frequencies of 20 Hz to 20 kHz. However, the speed of these sound waves can vary depending on certain conditions. This is the medium traveled in and the temperature. For the speed of the sound waves through air, a formula can be used of velocity being equal to 331.4 miles per second plus 0.606 miles per second divided by Celsius times the temperature in Celsius. For the shot, the temperature was 2.2 degrees Celsius. We rely on sound waves to communicate and for music. However, those are only audible sound waves. Ultrasonic waves are another form that is often applied in medical settings, as internal organs can be observed when ultrasonic waves are bounced off of them and then absorbed, this method being safer than X-rays without the risk of radiation. Infrasonic waves are also used for monitoring earthquakes and underground rock formations. Usually shot a basketball at a height of 190 centimeters, initial velocity of 24 miles per second, and a 70-degree angle above the horizontal. The temperature is 2.2 degrees Celsius. The ball hits the backboard at a height of 7 meters and 56 centimeters. In part A, the givens are acceleration at negative 9.8 miles per second squared, initial velocity at 24 miles per second, and the angle above the horizontal at 70 degrees, and the final speed is 0 miles per second. Whereas when the ball is at its maximum height, it will not have any vertical speed. The required is a maximum height, and to find it, we use a fifth kinematic equation as we have every value except for distance. After we rearrange for dy, plug in the values while multiplying the initial velocity by its launch angle to get the answer, which is rounded to 2 sigdics. For part B, the givens are vertical acceleration, negative 9.8 miles per second squared, initial velocity at 24 miles per second, the angle at 70 degrees above the horizontal, the initial vertical height at 1.9 meters, and the final vertical height of 7.56 meters. First, vertical displacement is found by subtracting the final height from the initial. Then we can solve for the final velocity on the horizontal by multiplying the initial velocity by the cosine of the launch angle, as horizontal velocity is constant, meaning the initial velocity and final velocity will be the same. After, we can solve for the vertical motion on the y-axis by using the fifth kinematic equation, plugging in the values and solving for the final velocity on the y-axis. Lastly, we can use the Pythagorean theorem to find the resultant vector of the final velocity, which gives us the magnitude of the final velocity when plugged in. For part C, the given required is temperature at 2.2 degrees Celsius. By using the equation for the speed of sound in air, we can plug in the temperature value as it is already in Celsius, and then calculate the speed of sound for the basketball, which will be 330 miles per second.